On this page of the seminar, we are going to be comparing two triangles. And we only can compare two triangles under certain circumstances. And one of them is called side angle side inequality. And so what happens here, if I have two triangles, let's call this triangle ABC and triangle XYZ. And what it says, if I want to compare two triangles, first off, two of the sides must match up. And as it turns out, if the angle, in this case, if angle A is greater than the measure of angle B, that tells me that I can compare those sides in the same order. So what I'm going to do is I'll put two arcs here on A, because that's bigger. And I don't know why I said B, sorry about that. We want to compare that to X. And you can only use this comparison if the two angles are between those sides, between the two congruent sides. Then it's kind of like what we did the other day in one triangle. I can shoot across, and that would tell me BC is going to be greater than YZ. That's called the hinge theorem, because you think of a hinge opening up like on a door. The bigger the angle, the bigger the space. The smaller the angle, the smaller the space. We call it side angle side because the two sides have to be the same, but the angles are different. If the angles are different, then we can make that comparison. These two triangles are not congruent, because notice I said inequality, so they're not the same. Now we can apply that on a design question here. Let me make sure, throw this a little bit bigger here, but not too big. So two families set sail on their boats from the same dock. So I'm going to put my dock right here. Here's my dock. And it says the Bains, they sail 3.5 miles straight north. So I'll go 3.5 miles straight north there. Then they're going to turn 85 degrees east of north. So if I keep on going north, but I'm going to go 85 degrees east, like so. And I'm going to see if I can move that 3.5 to the outside here. So it makes it easier to see. I'm going to move that right there. Okay. So what happens is, if they continued north, they would just be going straight north. But instead, they turned 85 degrees to the east. Kind of went into my picture there, sorry. And we're told then they sail 2 more miles. Maybe let's change the color on that. I don't like that color. Okay. So then we went 2 miles. And so right here is where the Bains ended up. Now compare that to the Croms. The Croms, they went 3.5 miles straight south. And then at that point, instead of keep on going south, they went east also. So they went east. So this is 3.5, and that's 2. And then, like we said, we went 95 degrees east of north. And this is where the Croms ended up at. Notice we got two sides the same. Now, the one thing to notice is these two sides, we don't have an angle in between them, though, do we? My angle is on the outside. So if I take 180 minus 85, this is 95 degrees. And if I take 180 minus 95, that's 85 degrees. So the person who's further away, notice 95 is bigger than 85. So the Bains actually went further. And that would be your answer. Notice, hinge theorem, your work is going to be drawing a picture and then going from there. Don't just tell me you know the answer without drawing a picture. That's not possible. And the same way when we do proofs. I've been helping a number of you with some questions, and sometimes I know the wording is kind of confused, and I don't think think you're understanding the proof, but there's so much words going on in some of those paragraph proofs, I understand you might be a little confused. But let's take a look at this proof. And when you do a proof, draw that picture. That's your work. You're going to write the answer on your computer or on a piece of paper if you're doing it, but really draw your picture out. So we got this picture. Now I've kind of cheated because I've got it right here on my seminar, but you got it too. Mark down PQ is the same as PM. Oh, that's kind of hard to show, isn't it? So I'm going to go PQ is the same. Did I type that in wrong? Oh, yeah. PQ is the same as PM. I don't think I did that right. Oh, yeah, I did it right. I just didn't notice. I'm glad I didn't stop the video. I did do it right. The one thing, notice these two triangles overlap. That's what I want you to notice here. So what we're going to be comparing is triangle P or M and P, and that overlaps with Q and P. Okay, so I've got those two the same. So why do I know that? It's given. Now, since these two triangles overlap, where do they overlap at? Well, if you notice, they overlap at PN, don't they? So let's trace PN on here. PN is in both triangles. What's that called? Well, that's a reflexive property. That part hasn't changed. Then if we notice, angle NPQ, this whole angle is composed of angle NPM and MPQ. Those two. Well, when you add two angles up and they equal the whole angle, that's your angle addition postulate. And then, since NPQ is composed of those two added up, I know NPQ is bigger than either angle. So we're going to say NPQ is greater than MPM. What's that reason? Well, that's what we call your definition of a inequality. Okay, so we're going to say definition of inequality, or you can say the comparison property, because we're comparing NPM to NPQ. So I'm going to say NPQ, my big angle, I think I'll put two arcs on that to show it's bigger, is greater than NPM. I've got the ability to use colors there. So then that tells me the side opposite angle P, NQ, is bigger than the side opposite angle NPM. That would be NM. And there is an application of our hinge theorem. So anytime you're comparing two sides in different triangles and two of the sides are the same, hence PM and PQ are the same, it's going to be the hinge theorem.